This video is sponsored by PCBWay.
Robots twist on your face when common sense speeds up. Where's that extra wheel? A huge impact. And we were just waiting for that next big impact. That was a wheel change. There might be a bit of a sitting duck here. Wow, what a hit. And as Command slammed down, we're going to cut it out in a second.
Alrighty, in today's video we're going to be going over the soldering for an SSP kit using the new budget speed controller, which is the 2x15 amp speed controller. Now this one looks all messed up because I tore the heat shrink off of it, since this is the very first one I ever got and I was doing some testing with it. The one that you'll receive will look like this. So you'll have heat shrink on it, which you will not have to remove, and either it will be customized or it will not. If it is not customized, which these first ones won't be, it'll arrive just like this. These wires will be slightly longer than the customized ones, and these wires will be way longer than you'd need, and of course you'll have this DNC plug and these JST connectors on here. So what we're going to do is we're going to cut all of these short, and we are going to basically stick these wires this way, wrap some tape around here, and then we are going to connect the motor wires to the motors and the power wires to an XT30 connector so we can get this guy ready to go into an SSP. You can also note in this SSP I actually bought some JST connectors separately instead of wiring directly to the motor boards, and actually installed JSTs on here. You could certainly do that as well. Instead of cutting these, you could buy some JST connectors from Amazon or whatever, solder those to your motors, and then you'd be able to quick connect and disconnect. The customized version of this will have much shorter wires that should allow you to do that. But right now, these ones are off-the-shelf ones, and these are like the beta run that I'm selling. So I'm just going to show the whole process for this guy right now, and it'll be a lot simpler for the ones that arrive already customized. First things first, let's start cutting. So got my wire cutters and strippers here, and what we're going to do is, this does not need to be precise at all, but I happened to measure it a bit ago, so we're going to try and get this power connector to be about 90 millimeters. And then the motor wires from the pads will be about 80 millimeters. Now we can toss these aside for now, and this aside because we won't need it. Next we are going to strip the ends of all of those wires. So this is a 18 gauge, and then these I believe are 20 gauge. Probably says on there if you have the wire in the right place, because the label's repeated every so often. Next we're just going to twist all of them. And then I'm going to grab my OmniFixo, if you have a helping hand, so that can be helpful for this instead. And then I'm just going to grab the wires in pairs here so I can tin them a little bit more easily. Grab a soldering iron for this. Temperature doesn't matter too much. I'm going to set it to about 270 Celsius. Don't ask me why, I just do soldering stuff in Celsius. I do a lot of this stuff in metric just because it's more transferable. And I don't have my fume extractor on because I want to be able to be heard on camera. But I would recommend that you have one on. If you strip too much wire, you're going to be tinning your wires. A little pro tip here: tin the wire first before trimming it, because then when you trim it, it'll be a super nice clean edge instead of having little frayed bits. Now, I'm going to grab a XT30 connector, and I like to use my little XT30 soldering jig for this because I find it's a little bit more convenient. You'll see I marked it plus and minus. The positive, or the red wire, goes to the flat side, negative or black wire to the rounded side. Now, if you don't have heat shrink, you can use electrical tape, but I personally prefer heat shrink, so I'm going to get some little nubs of heat shrink that I've already cut and slide them on my power wires now. Now, I'm gonna tin some solder onto the XT30 itself. This is out of focus, I apologize. I only have the camera's built-in monitor to compare with right now, so I can't really tell. Now for this, you want to make sure your iron temperature is not too hot because you can melt these connectors, but if you're fast enough, it won't really be an issue. So we are going to melt the solder on the connector and on the wire. Shove them together. Wait for them to cool. That was a terrible job of shoving them together. There we go. Blow to cool it faster can help. Repeat for the negative side. Nice little tug to make sure they're secure. Slide heat shrink over. Boom. There we go. Now, motor connections. I may have cut these slightly shorter than would be ideal, but they only really need to reach from here to the motor and here to the motor. And of course we can flip this if one is just a little shorter than the other. So the way that I have this connected, I have it upside down like this, and then yeah, M2 is to the left, M1 is to the right. Of course, when you're just soldering to the motors, it doesn't matter which one's left or right, because you can put the motors in either slot. And we are doing red to red, and then we are doing black to black for both motors. So pretty straightforward. So to start off with, you've got your motor power boards. You want to get those with the red on the red dot, black on the not red dot, as you'd expect. Remember, as always, when you're soldering to a PCB, your goal is not to get solder around the tab. Your goal is to get solder to stick between the board and the tab, and same goes for wires. Your goal is not just to get solder on the wire. You could end up with a cold solder joint that does not look very good and does not provide a good mechanical connection, even if it does provide a tenuous electrical connection. So you really want to have a large surface area covered between the wire and the pads here. Let me zoom in again so you can see better when I do the wires here. So now we grab the speed controller, and again, because it doesn't matter which motor is which right now, we are just going to do it like this. So I'm going to do black to black. Now you have to be careful here, because if while you're holding the wire, of course, the longer you have to apply heat, the hotter it'll get. So I'm going to turn the iron temp down to 230. And then that should mean that I don't have to hold down the wire for as long, because the solder will cool faster. Just like that. The OmniFixo can help with this, but I find it's a little bit more work to set it up for this than to just do it by hand. Even if the risk of burning myself is a little bit higher this way. It's hard to apply the amount of pressure, just the right amount of pressure, you know? Note, because I already tinned the wire, there's solder on the wire, so that starts to liquefy, and then that hot solder can heat up the solder on the pad, and then when that liquefies, they both meld together. If you didn't tin your wire beforehand, just trying to conduct heat through the wire to solder that's already on the pad probably wouldn't work that well, because there isn't enough surface area contacting it, because you've got rounded edges on the wire strands. instead of a nice conforming blob of solder. Alrighty, the Dragon motors really like to magnet together, but that's that for the drive motors and for the speed controller power connection. So now all that I'm going to do is grab a little bit of Kapton tape, or you can use electrical tape for this, and I'm going to strap the signal wires to the speed controller just so that they are strain relieved, because they have to make this tight bend here. I don't want them to get tugged at all, so just gonna do that. Of course, my tape stuck to itself, so it looks like crap. Boom. Just tape them like that so that your strain relief is here instead of it being like forced around here and you could potentially break them off there. Alrighty. Alright, I've got another motherboard soldering video that I will link to in the video description, so let me do that off camera and then I will get back to it and show the radio setup for this guy as well. Or I guess I can do it on camera and time-lapse it. When I first did this motherboard soldering process, I did it a little differently from how I'd recommend doing it now. Previously, I would solder on the FS2A after pushing it down and clipping all the pins, but I found that's kind of a huge waste of time. So now, I just stick it so it's like just at the surface. And then, once you get like a couple of the pads on there, it'll kind of stay at that height.
While the motherboard soldering's happening, I'd like to thank today's video sponsor, PCBWay. Currently, PCBWay is having a 9th anniversary promotion, so that's 50% off of some 3D printing and CNC machining orders. There's a ton of coupons. There's coupons on flexible PCBs, regular PCB fabrication, PCB assembly, and like I said, CNC machining, which I've used for a number of projects in the past, including having a beta motherboard that was manufactured by PCBWay, and a couple of chassis that were CNC machined by PCBWay that I'll be using in future videos. So check them out at the link in the video description.
There we go. Fully soldered motherboard. Alrighty, I'm going to show how to configure this. I'm going to use an old SSP battery. This is not the style that ships with the kits anymore for this. So we've got battery connected, the new power switch keys. I still got some of the old ones, so it'll be a while before these are shipping with the kits, but it's the same thing. It's just not an uncomfortable flat metal handle. And then, so we turn that on. After we plug in the battery, we see the receiver is not in bind mode. Whoop, come on. Turn it off, hold down the black button on the receiver, turn it on to put the receiver into bind mode, so we now get rapid blue flashing. Alright, got a brand new radio model on here. Turn off, hold bind button, turn on. Blue LED starts being a slow flash, off and on, boom, problem solved. We now have the radio bound. Do I even have a servo I need to prove it? I don't think I have any working servos at hand at the moment to probe it, but trust me, I guess. So let's get these guys over in camera. So we should be able to simply connect power to any of the X230s. You hear that little bloop. And then we just want, I'm going to unplug the batteries when I do this just because it's a little in the way. So we want channel 1 to be this white pin here. So the inside, that first one, and then the yellow right next to the white. Like so. Just to make it super clear, I'll zoom in. That's exactly how I have it connected here, though it's covered in hot glue so you can't really tell. So channel 2 signal is that yellow wire, channel 1 signal is that white wire. Now, if I connect the battery and have it turned on again, we now have the motors spinning. The question is, are they spinning the correct directions? Well, the answer is no, they are not. But that's okay, because we should only have to do one thing to fix that. Hold the OK button, down to function setup, OK, OK for reversing. And we are going to reverse channel 3, hitting OK to cycle through and up or down to change, and channel 1. So 3 changes it so that the servo channel is reversed. 1 changes it so that the forward, backward, and steering are correct. So that is how you should be able to get this to work, and then you hold cancel to confirm because the FSI6 is stupid. Now you'll notice one other thing that you'll want to do with this, if you're getting the beta run of these, when you push up on the stick and let go, they coast. Usually we prefer braking for driving, so to control that, I'm going to temporarily open up that reversing option again and put reversing to normal. I need to look at my little cheat sheet here. We are going to hold the stick to the lower right to change braking on, and then we are simply going to turn power back on, and then wait a second, and then let go. And now you'll note that they stop instantly instead of coasting. One other thing you might want to change is the lower left thing. To do that, you have to power cycle off. Off, stick to the lower left now. I don't know why I'm doing this with this hand. And then on. And that, let's see. I have to trim these a bit too. I don't know for sure if that does it, but I think that sets the speed to high instead of to medium by default. That should be the only thing that you really need to change on here. So I'm gonna now hit down to reverse channel 1 again so it drives normally again, then hold cancel and confirm. Now I have noticed, I don't know if it's something with just having mismatched motors or if it's something about this speed controller, but when you push up on the stick slightly, you'll notice one motor starts spinning before the other one. To fix that, you're just gonna wanna trim left or right with this guy. You'll play with it and you'll see which one improves it. See, now it's the other one starting before, but I went too far. So now they start at the same time, and you might have to play with this once you install it in the robot because there could be slightly different friction on either side that might change exactly when one starts or the other, but that'll be how you get the robot to track in a straight line. I'll make a future video where I show this with the wheel motors actually in the bot, and it'll make a bit more sense. But for now, just know that you want to use this side-to-side switch to adjust the steering, and basically it's almost like you're shimming it to one side, or you're basically biasing it to one side so that the motors start at the same time. So that's all you need to know to get your beta speed controller, your budget speed controller set up with your SSP kit. If you were to buy one of these in a month or so, this should come already with the correct defaults for those things that I had to change, so you shouldn't have to enable braking or change the acceleration or anything. It should just work out of the box with none of that configuration stuff. But it is nice that it requires turning the bot off and on again with the stick at a diagonal to reconfigure it, because that means that the likelihood of that happening by accident in a fight is basically 0. And there's no risk of like a little switch or button getting hit by some debris or just the shock load in a fight. So that setting will be baked in every time you power this on, and it will just work the way that you expect it after doing that configuration one time. It also will stay that way even if you switch receivers or anything, because it's held on the memory on the speed controller, not on your receiver. So yeah, that's pretty much everything you should need to know to configure an SSP kit using this speed controller.